This is Plant-Based Briefing, Meet the Animals, the Mouse, by Lexis Ly and Sara Roh at Society for Humane Science at forhumanescience.org. And I'm Marian Erickson, and this is the curated content plant-based podcast for people short on time but curious about plant-based and vegan living. I narrate articles with permission, and today's article is from the Society for Humane Science. They're a Canadian nonprofit working to promote better science without animals. Their mission is to build an ethical culture of science that respects animal life by promoting the reduction and replacement of animals in testing, research, and teaching. So now let's get to today's plant-based briefing. Meet the Animals, the Mouse, by Lexis Ly and Sara Roh at the Society for Humane Science at forhumanescience.org. To gain a better understanding of how we can achieve better science without animals, it is important to first understand more about the animals commonly used for scientific research. Today, let's dive into the inner world of the mouse, the most commonly used animal in science. Mice are not rats. Although mice and rats are both rodents, they're not the same animal. You can distinguish a mouse from a rat in many ways, but you can most easily tell by their size. Mice are generally a fair bit smaller than rats, and by the shape of the nose. Mice noses are more triangular in shape, whereas rat noses are more round and blunt. But don't get them confused, because mice and rats do not get along. Mice are sometimes prey for rats. However, mice and rats do have a lot of things in common. For example, they're both nocturnal and have relatively poor eyesight, but what they lack in vision, they make up for by having strong senses of smell, taste, and hearing. Mice teeth constantly grow. A wild mouse's diet is made up of many hard foods such as nuts, which tend to wear down their teeth over time. This isn't a problem for the mouse because mice have teeth that are always regenerating. A mouse's teeth grow approximately 2 to 2.8 millimeters per week. But if they're incisors, the front teeth, start to misalign, their teeth can grow in abnormal directions and actually injure the mouse. This painful tooth overgrowth is called malocclusion, which can lead to malnourishment and eventually premature death, since mice would no longer be able to eat food. Unfortunately, this condition is very common in laboratory mice. Mice make beautiful homes. Despite their small size, mice enjoy creating large and complex spaces to live in. Mice are natural nest builders and will keep themselves busy by collecting materials from around the cage, such as bedding to sleep in. When kept as pets, you're likely to find a mouse stuffing bedding into a hut or creating a nice pile of bedding in the corner of the cage. One way to help mice make their beautiful nests is by providing them with materials they can shred, such as paper towels. Mice have even shown to designate a bathroom area away from the bedroom. When mice are given enough space, they will separate their space into clean and dirty areas. Scientists believe this segregation of space has evolved in many species to protect themselves from diseases. Indeed, mice are wonderful, clean homeowners when given the chance. More fun facts. Mice make great pets. Unfortunately, mice do not have the best reputation since we often view them as vermin, pests, or vectors of disease. However, mice can actually be loving, intelligent, and curious animal companions. They're best kept in groups of 2 or more of the same gender, since they're very social creatures. Mice can even be trained to do fun tricks just like a dog. If you're a fan of anything small and cute, pet mice often grow to be only 5 to 7 inches long and weigh only a few ounces. If you're interested in having some mouse friends, check your local animal rescue agency, but be sure to do your research first so that you know exactly how to take care of them and what they need. Mice can squeeze through a dime-sized hole. Mice can grow from 2.5 to 18 centimeters, with the smallest species being the African pygmy at 3 centimeters. Despite their size variance, most mice species are able to squeeze through holes the size of a dime. This is all possible due to 2 main factors, their fur and their flexible vertebrae. These furry little creatures have more fur than you think. 2/3 of a mouse's diameter is due solely to their fur. This creates the illusion that they're bigger than we think. However, the greatest trait of a mouse that allows them to fit through the small holes is their flexible vertebrae. Sometimes people may refer to it as the mouse's collapsible skeleton, but this is incorrect. Unlike humans, their clavicle or collarbone is able to slope towards their chest, allowing for more compactness of their body to fit through extremely tiny holes. Mice can sing. Known for their squeaking, mice are actually capable of singing tunes. The Central American species, Scotonomys tigina, also known as Alston's singing mouse, demonstrates this amazing and natural talent. The main purpose of singing for these mice is courting a mate, although it's mainly male mice who sing these love songs that are inaudible to the human ear. A recent study found that if a female mouse is interested, she will sing back in response. Furthermore, there has been evidence that male mice compete with each other with their singing, taking turns in a glee-like singing duel. Mice in science. In 2018, 1.5 million mice were used in teaching, testing, and research across Canada. Note, in the U.S., over 110 million mice and rats are used in research. This makes mice by far the most commonly used animals for science. What's more, these numbers do not take into account animals that are not used, animals that are only used for breeding purposes, or animals that are used at non-Canadian Council on Animal Care certified institutions, meaning the actual number of mice used in Canadian science is likely to be much higher. Researchers often use mice because they're small, easy to maintain, have similar development to humans, and were the first mammalian species to have their genome fully mapped. However, the astonishing number of mice used in science calls into question the sustainability of using animal models in science, especially when the data gained from mice often doesn't translate well to humans, in the cases where mice are being used for the research and development of new drugs. In fact, recent estimates show that roughly 95% of drug testing in animals, which is mainly mice, fail at human clinical trials. This has led some scientists to call for more caution when scientific results from mouse studies are published. For instance, check out @JustSaysInMice on Twitter, where researcher Dr. James Heathers is always quick to point out that people should rein in their excitement over results from mouse studies. Other scientists are working to avoid the use of mice and other land animals completely, and instead are developing human-relevant non-animal methods, like organs on a chip, 3D bioprinting, organoids, and other amazing biomedical technologies. The 3 R's, replacement, reduction, and refinement, is a set of principles for the ethical use of animals in science. Although the 3 R's have been in place for over 50 years, we're still seeing an increase in the use of mice over time in Canada and elsewhere. This is largely due to the large proportion of mice in research that are genetically engineered. In her PhD research, Dr. Elizabeth Ormandy studied the trends in the use of genetically engineered animals in science and found that the increased use of genetically engineered animals was driving an overall increase in the use of animals in science globally. Some scientists argue that creating genetically engineered mice makes for more accurate animal models. However, others, like Dr. Jared Bailey, argue that despite advances in genetic engineering technology, there remain some serious scientific and ethical problems with genetically engineered animals, linked here. The concerns raised by Dr. Bailey and others further emphasize the need for the development, validation, and implementation of non-animal alternatives, rather than reliance on genetically engineered mice. We're working to achieve better science without animals. We're training the next generation of scientists. We've created and now deliver a third-year undergraduate course called New Approach Methods in Biomedical Science, which focuses on the various cutting-edge technologies that are replacing the use of animals in science and promising to be better at predicting the safety and effectiveness of new drugs. And we're working on policy reform for Canada. There is no national legislation for the use of animals in science in Canada, despite the fact that animal research is a federally funded activity that uses your hard-earned tax dollars. We're working to change that. You just listened to Meet the Animals, the Mouse by Lexis Ly and Sara Roh at Society for Humane Science at forhumanescience.org. And I'm Marian Erickson, your host. And I've read a number of episodes from nutritionfacts.org, and Dr. Michael Greger is often talking about studies that use mice and how you have to be very careful interpreting the results from them because they often don't apply to humans. You might want to check out episode 303, How Foods Are Tested for Depression. It's an eye-opening one for sure, and I'll put a link to that in the show notes. So please share this episode with anyone who might benefit, and thanks for listening.